Hey there, grade 8. Welcome to lesson 1.3 from Math Makes Sense. Today we're talking about measuring line segments. So when we're measuring line segments, specifically what we're talking about is, say we have a square here. Okay, this square happens to be 4 by 4. Our line segment is going to be one of the edges. That's what we're referring to when we're talking about measuring a line segment. So there's different squares that we could actually draw within this, right? We could do this whole thing. So we could go 4 by 4. So we would have a square of 16 square units, and our line segment, or our square root, technically, would be 4, okay? What if we were to draw it smaller? So if we were to kind of make our circle, or our square go like this, okay? So then we would have 3 by 3. Our area would be 9. Our line segment, or our square root, would be 3. All right? Now, what if I'm going to mix it up a little bit? Okay? What if it wasn't put in perfectly? What if it went something like this? Okay? What if we had a square that wasn't necessarily perfect, okay? Because not all squares are meant to be perfect. And what I mean by perfect is it doesn't have an exact area. We can't look at this and we can't necessarily say, okay, I know that the area is this, so that means my line segment is going to be the square root of it, because it doesn't work out to necessarily be what we would consider a perfect square, where we have a whole number times a whole number. Because it's easily possible to have a square with a line segment or side length of 2.5 centimeters, right? So then if that's 2.5 centimeters times 2.5 centimeters would give us our area. But that's not what we call a perfect square. A perfect square is when it becomes a whole number. So what can we do to actually figure out what the side length is? Well, there's a couple things that we can do. For this example, what we're going to do is we're actually going to cut it and turn it into, well, let's see, what kind of shapes do we have here? It looks like we have 4 different sections, but it looks like they're broken up into triangles. Okay, we know how to work with triangles, because last year in grade 7, we realized that the area of a triangle equals base times height divided by 2. So I have 4 identical triangles. They're all the exact same. So I could say my base is I'm counting the units. So 1, 2. So area equals 2. My base is 2 times my height of 1, 2 divided by 2. So my area equals 2 units squared. All right. Now, how many do I have? I have 1, 2, 3, 4 triangles. So I'm going to say my area of my square equals 4, because that's how many triangles I have, times the area of one triangle, which happens to be 2. So it equals 8 centimeters, or whatever units, squared. Okay, now, what it's asking me is, what's the side length? What's the side length? What's the distance from this line to this line? Well, I'm going to say that my length is equal to the square root of 8. Okay, it's equal to the square root of 8. Now, that works out really nice, because it just gives me 4 triangles. So what if I erase these triangles, and I'm going to come up with a different square. Okay, I'm trying to keep my lines as good as possible so that you can still see. Maybe I'll redraw them quickly. Right, so you can still kind of see that it's a 4 by 4 section. All right. Now, what if my square goes like this? Okay. So I still technically have my square. All right. But now I've got something that looks a little bit different. Okay, so what's going to happen? I'm going to use green to show what's actually going on. I can still technically make triangles, but I'm going to have something else in the middle. Well, let's look. What do we have in the middle? Well, we've got this wonderful square in the middle. Okay? Once I have my square, I'm going to try to make triangles from there. So wherever my square goes, I'm going to try to connect to one of my corners. So if I follow this out, here, 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 and here, I have, let's see, 1, 2, 3, 4 triangles and 1 square. Okay, I have 4 triangles and 1 square. So, can I calculate the area of everything? Well, yeah, absolutely. Let's see. Let's look at my square first. So my area of my square equals base times height, which equals, I've got 1, 2 units times 1, 2 units, which gives me 4 units squared. Now I'm going to look at one triangle. So my area of a triangle is going to be, let's see, I've got 1, 2, well, I'll go to the top one, sorry. 1, 2, 3, because technically it goes all the way to the corner. So 3 times 1 divided by 2. So let's do the math. I've got 3 divided by 2, which equals 1.5 units squared. Now, how many triangles did I have? I had 4. So I'm doing 4 times 1.5 equals 6 units squared. Now I need to add these together. So I'm going to have 4 plus 6 equals 10 units squared. So that's my area for the entire square. All right? What's happening now? What's my side length? My side length is going to be considered the square root of 10. Okay, that's going to be the area of my side length. All right? So I'll show you in a picture. I'll erase this first, otherwise you won't be able to see it. Okay. See, hopefully it shows up. There we go. So, as we can see in this picture, okay, this was our initial square. What's going on here? It's actually going and it's making these little triangles, and it's leaving a square in the middle. Okay, that's allowing us the opportunity to calculate the area of each of these individual triangles and the square, and then all we do is we say the square root of that is going to be our side length. Okay, so this is a really not super easy concept for a lot of people to try to figure out. So I know you're going to have a lot of questions about it. How can we get there? There is one other method that I want to show you, and this is kind of the opposite. All right. So if we're looking at this one over here, what we have is we have our small square. Now, instead of necessarily calculating the area of everything on the inside, they're actually going to find a bigger square. Okay? They're finding a bigger square. They can calculate the area of this. So we have 1, 2, 3 units by 1, 2, 3 units. So we have 3 times 3 equals 9. Don't confuse you guys. 3 times 3 equals 9. And then they're going to go and calculate the area of each of the individual triangles. So we've got a base of 2 and a height of 1. So 2 times 1 divided by 2 equals 1. So each of these is 1 square centimeter times 4. So 1 times 4 equals 4. Okay, so we have the whole big square. So this is JKLM. But we're trying to figure out the area of ABCD. So the shaded space. So what are we doing? We're taking this whole big square and we're calculating what the triangles are going to be, and we're subtracting that because it's technically not part of our square. It's not shaded. Each of these little triangles are not shaded. So we have to subtract from the big square, which is 9. So this is 9. And this is from each 4 of the triangles. Okay? That's where we get the 4 from. Each one of them is a singular one. So we're going to go 9 minus 4 equals 5, or we're going to say the square root of 5 is equal to our side length. Okay, so that would be the distance from A to B, or A to D. Okay, any one of those distances. So that's how we actually go about calculating it. So there's 2 methods. There's one finding the triangles inside. If I wanted to find the triangles inside this one, I would go here. There we go. And then we would have, so we could do the same thing. So we have 1 square unit here, and then we would calculate what the area of each of those triangles are. In this case, it's 2 times 1. So 2 times 1 divided by 2 is 1. And then we have 4 of them. So 1 times 4 is 4, plus our 1 in the middle gives us 5, and we get the exact same answer. So no matter which method we actually go about doing it, we end up getting the same thing. So we're going to have you play around with actually finding the line segments for a bit, and any questions, and I know you will have some, because this is not an easy concept, I'm going to have you bring them to the Zoom session, and I can help you guys out there. All right, have a great day.